Hello everyone! Today, we are going to show you on how to solve irrational inequalities. So we have 2x over x plus 1 is greater than or equal to 1. The first thing we will do is that the 1 on the right side must be 0. So let's just transfer our positive 1 to the left side of our inequality. So that is 2x over x plus 1. So if we transfer positive 1, that will become a negative 1. So 2x over x plus 1 minus 1 greater than or equal to 0. And it was said that the 1 on the left side must be a single fraction. So after that, we can now combine these two. Let's subtract our negative 1 to our rational expression. So our LCD is x plus 1 since there is no denominator in our positive 1. So let's just copy 2x and then let's just multiply our LCD to our negative 1. So that is negative 1 times x plus 1 greater than or equal to 0. Okay, now let's distribute that is 2x. Negative 1 times x, that is negative x. Negative 1 times 1, we have negative 1. Then over x plus 1 greater than or equal to 0. Now let's simplify or combining like terms. So 2x minus x, that is x minus 1 over x plus 1 greater than or equal to 0. So now it is general term. So we can now get our critical values. So to solve it, let's just equate to take the value of x. So x minus 1 is to 0. And the denominator, x plus 1 is to 0. Then let's solve for x. Let's transpose that 1. So we have x equals 1. Then x equals negative 1. Now, we are going to put that positive 1 and negative 1 and the number line. So on the number line, it's separate. Negative should be on the left side and the positive on the right side according to the number line. So let's use negative 1 at the left side. Our positive 1 is at the right side of our number line. So our number line will be divided into 3. So we have 3 intervals. So in our first interval, x less than negative 1. So there's a negative infinity. In our second interval, x is greater than negative 1 but less than 1. So our third interval, so we have positive infinity and x is greater than 1. So we have 3 intervals. So we can now make a table of signs. So in our table of signs, we need our 3 intervals. So first, we have x less than negative 1, then x is greater than negative 1 but less than 1, and then x is greater than 1. Now let's get our test point first. So our test point must be involved to our 3 interval. So for x less than negative 1, we can put negative 2. Then here, x is greater than negative 1 but less than 1, so this is 0. And then for our x is greater than 1, we can put 2 in that. So these are what we're going to use in our table of signs. So after we choose the test points, let's get back to our rational inequality. So we have 2 functions, x minus 1 and then x plus 1 and also let's put our rational inequality. That is x minus 1 over x plus 1. So all we have to do is to substitute our test point. So here in our functions. And then let's get our sign. So let's try. Negative 2 minus 1, that is negative 3. Then negative 2 plus 1, that is negative 1. And then negative divided by negative, that is positive. So let's just focus on our signs. Next, 0 minus 1, that is negative. All plus 1, that is positive. And the negative divided by positive, that is negative. Last, we have 2 minus 1, that is positive. Then 2 plus 1, that is positive. And then positive divided by positive, that is positive. Okay, now after we got our signs, let's get back to our given general form. So as you can see, if we divide our x minus 1 by x plus 1, it must be greater than 0. So now, what are the numbers that is greater than 0? So of course, those positive numbers. So in our table of signs, we have 2 positive. So therefore, our final answer is x less than negative 1 and x greater than 1. So if you notice that there is an equal in our rational inequality, so it means we have to put equal symbol in our inequality. But it is not type of domain to our negative 1. Since our denominator will become 0 if we put negative 1. So therefore, we must not involve our negative 1 to our here x less than or equal to negative 1. So let's erase our equal sign. So in interval notation, our answer is x less than negative 1. So we have negative infinity. And negative 1 open, RR, that is union, and then x greater than equal to 1, so that is closed, interval 1 to positive infinity. So in graph, negative 1 will be open because it is not part of the solution. So R1, there's a point or a shaded one. So our solution set is going to negative infinity, while at the right side, going to positive infinity. So this will be our final answers. Bye-bye!